Hi, everyone. I am Dan Murphy, chiropractor. Hey, this month is my anniversary in chiropractic. I will end my 44th year and begin my 45th year as a chiropractor. And I have biases in my thinking, so I want to share them with you, in that I am board certified in chiropractic orthopedics. I think orthopedically. So my clinical approach is orthopedics. My clinical expertise is in trauma. And consequently, I put together a small presentation that has to do with trauma, brand new stuff that I've never showed anyone before. So for those of you that have heard me before, you haven't seen the majority of what I'm going to share with you this day, because it's brand new and it's based upon a brand new book called The Brain and Pain. And it's a 2022 copyright. The author, his name is Ambram. He's out of Columbia University. So I'm going to show you some really cool things. I'm just stalling for a second as everyone is filling the room. As I'm saying hi to you, the title of this presentation is Exploring the Application and Science of Low-Level Leisure Therapy. I will start off with about a 20-minute presentation on something brand new. You almost certainly will want a copy of it. If I was listening to me, I would want a copy of it. It's 15 slides. They are not a PowerPoint. They are a PDF. And right after the talk today, you don't need to take a ton of notes on my end. If any of the slides that I have, that it's 15 pages, I will send it up to Erconia right afterwards, and they will figure out how to make it available to all of you. Just using that to start, I would also start by saying, and I'm part-time faculty at a chiropractic college. I just finished my 12th quarter senior class yesterday. Next Monday, they will take their final examination. I've been at the college now for 41 years, and I also am a graduate of Western States. When I went there, it was Western States Chiropractic College. Now it is the University of Western States. As an ironic kind of ego-boosting note, right now, this year, 2022, I am Alum of the Year for the University of Western States. It took them 44 years to acknowledge me in such a fashion, but they did, and I'm really appreciative. And just sort of going through the 15 slides that I put together with you, here goes. We start with this, just a little bit of this. I know that I'm not really in favor of some of the terminology here, but I think some of the science in this particular study is definitely noteworthy. This study coming out of the journal Dose Response, as you can easily see there, it's from Harvard and Boston University. And what I wanted you to see here more than any other particular thing is this paragraph right here. So it's on the top. It says, LLT, low-level leisure therapy, is not an ablative or thermal mechanism. Stop. We do not use lasers that generate heat. If you look at our written informed consent, which, by the way, all of you, any of you that want a copy of my written informed consent, you are welcome to have it. You would just email me or Michelle, probably Michelle, and she was happy to send it to you. And we don't save you, we don't market you. It just to show you kind of what we're up to, because we're exceptionally experienced in every facet of clinical practice. We talk about laser in our informed consent, but we make the point, our lasers are not thermal. They cannot burn ever under any circumstances. The laser is not an ablative or thermal mechanism, but rather a photochemical effect comparable to photosynthesis in plants, whereby the light is absorbed and exerts a chemical change. Sorry about this little glitch here. Michelle, if you're on, can you bring me my marker? It's in the front. And she said, sure, I heard her say that. Michelle, for those of you who don't know, is both my wife, and she's the main chiropractor in our clinical practice. She's a Logan graduate, and she's been on the job for 38 years. And so you'll see her pop in here in just a second, as I forgot my stylus to make a few marks on this. I left it in the charger. I want to just emphasize right here that what we do is not thermal. Thermal is different. Thermal is photophysical. We are photochemical. We're doing a chemical change. There are many that are fun to talk about, many, but the consensus, including on this article, is that these non-thermal, non-ablative lasers can instantaneously and meaningfully elevate the production of adenosine triphosphate. To understand that in its totality is a 12-hour class. I'm going to talk to you for about 20 minutes and then turn it over to the engineers from Erconia. The next thing I just wanted you to see is just all of the different really cool applications that lasers have for so many different things. It's interesting for me. I'm kind of a musculoskeletal chiropractor. I'm doing back pain and neck pain, yet Michelle, you just saw kind of jump in, she does a lot of other things, including she does strokes. And that's, I used to watch her do some of her stroke patients down there in Arizona before she came up to be with me 8 years ago. Really interesting work to see how is it happening? How can lasers help these people and help them as much as they do? When you just look at the literature on it, the literature nicely stated here, current research about the mechanisms of laser effects inevitably involves the mitochondria. Mitochondria, hey, if you read the current 2022 book by cardiologist Stephen Gundry, the heart transplant surgeon, called The Keto Code, he says that the key to longevity, the key to health is mitochondrial uncoupling. That's what lasers do. They uncouple certain physiological processes within the atoms of the mitochondria, resulting in significant increases in the production of ATP while simultaneously dropping the production of the free radicals. It's a very interesting system. And as just showing you the words, you get more ATP synthesis. And if I just did a big talk on protein synthesis. Protein synthesis is a very expensive proposition. Lots of energies are required to go from your genetic material to your DNA to proteins. And consequently, if you influence the mitochondria in a way that you get more ATP synthesis, because you do, the result is you get better expression of your genome. All of the structure, all of the enzymes, all of the receptors, everything that is made out of protein in your body, you get more and better if you can elevate the production of adenosine triphosphate. And you can do it throughout the life cycle. As we get older, we just naturally make less ATP. You can compensate with that if you figure out how to apply low-level laser therapy, which can be done even if you don't have complaints. Even if you just want to enhance physical prowess, if you want to enhance cognitive abilities, both of which are in the literature. The enzyme that is influenced is called cytochrome C oxidase. I'm a fan of it. It was discovered by Otto Warburg. Yeah, the same Otto Warburg who was the cancer researcher, got the 1931 Nobel Prize. He should have got the 1926 and the 1944 Nobel Prize. He did not, but he should have. Cytochrome C oxidase is a fascinating topic for anyone who is biologically inclined, particularly if you are evolutionary biologically inclined. That's the photo acceptor. And this is when the last time I did an actual court case in low-level laser therapy. And so Erconia really doesn't even know what I'm going to do today. They've never seen this presentation. And I'm going to kind of put these guys on the spot and ask them some questions momentarily. But one of the questions is that I do PI, and I picked up this book. I'm reading everything I can on spine trauma because that's my job. This one here is called Painful Cervical Trauma by David Tollison. So when this book came out in 1993, brand new book, I pick it up, I'm reading it, and I'm thinking, man, this is a good book. And on page 118, this book has a section on laser therapy. I don't know if you guys can see that at all, right above my finger there. And it talks about how if you know how to use red laser therapy, you can accelerate the healing of any injury, including whiplash trauma. So I'm into that because I'm a chiropractor and I'm dealing with these people. This is the bulk of my clinical practice. And in all the years that I've been on the job, I've had 70 associate doctors. I've had the best clinical experiences. And I'm thinking, this is for me. And I got laser and it worked great. And first time I did a jury trial with laser, I lost it. And I lost the trial, not because I was unprepared or incompetent. I lost it because the laser I chose did not have FDA market clearance. So, my co-speakers this day, it'll be Travis and Steve. I'm going to ask them, what does it take to get an FDA market clearance? And because they are at the time, the only company that had any FDA market clearances for low-level laser therapy. And the result is I switched to them because if you're doing med legal, you have to, or they don't even let you use these devices when it comes into the med legal arena. If you take a look at this one here, it is a really interesting little abstract. I've used this one in my last PI trial, which was 2018. So I haven't done an actual trial on PI since 2018. Interestingly, it went for $180,000. I constructed my own direct examination about how to get the information that's in my brain out in front of the judge and the jury. You can't lecture like I'm lecturing to you now. You have to just answer questions. And so I constructed the questions and we went over them. And one of the questions was, can you reference even one study that says lasers are effective in both reducing pain and accelerating healing? And so I said, well, yeah, it was a 2018 case. This was October of 2017 study. It's PubMed index, which means it's logged in the National Library of Medicine of the United States of America. The judge allowed it as evidence. It's from the journal Alternative Therapy and Health Medicine. A review of the literature on low-level laser therapy benefits from non-pharmacological pain control and chronic pain and osteoarthritis. Clearly, it goes over how they reduce pain, how they're non-ablative, they are non-thermal. In fact, even in this article, they refer to it as cold laser. There's no generated heat at all, and yet it drastically accelerates healing. Healing stimulation, and again, also interesting. Try not to make you too much vertigo as I'm flashing that up and down on my iPad. Cytochrome C oxidase. I mean, that's where it works. That's the rate limiting step in the mitochondrial production of adenosine triphosphate. It's also critical that when it doesn't work well, you generate excess levels of free radical that then accelerate the demise of your mitochondrial DNA, which puts you into a very bad loop called the death spiral. If you ever seen those studies by Ron Del Pino out of Harvard. In any case, this is a really great abstract on it. Reads really well. My actual point for the remaining 8 minutes that I have with you before I turn it over to Travis and Steve is this book here. Most all of us are familiar with Daniel Amen. If you're unfamiliar, he is a neurologist out of UC Irvine, University of California, Irvine, and he's got a show on PBS on the brain. So I bought his show on the brain. I like all of his books. His first book came out in 1998. This book here, he writes books pretty regularly, probably has a dozen or so that are out there. This one came out from 2017, and it's called Memory Rescue. And in Memory Rescue, you see this, the prefrontal cortex, that's your forehead behind it, which is thought to involve with focus, forethought, judgment, and impulse control, is the area of the brain most densely populated with mitochondria. So right away, I see something relevant because we are very clinically experienced. We have people with pain in all kinds of different spots of their body, and we just notice anecdotally that if we put the laser on the medial prefrontal cortex on their forehead, they seem to respond excellently on pain no matter where it is in the body. Well, it would make some sense physiologically, and when you realize that that's the spot that is most densely innervated or constructed with mitochondria, and the mitochondria controls the physiology of the entire neuron, and we are activating, which we'll see next, what's known as the suprasegmental descending pain inhibitory control machinery, which you can learn really in great detail if you go through neurology diploma class, which I've been through the whole thing twice. It doesn't mean I know what they're doing. I'm still orthopedically minded and orthopedically angled in my clinical approach, but increasingly we're getting into the neurology thing because I'm understanding it better. This article here, the medial prefrontal cortex and the mitochondria, this is the book that just has really shaped my world recently. If you read about Richard Ambron from Columbia University, The Brain and Pain, it's a 2022 copyright. The reason I have this here is because he says that pain control central is in the mesencephalon, the top of your brainstem. So this is an axial cut through your brainstem just before the brainstem attaches to the brain. And there's a spot called periaqueductal gray. This is pain control central. Interestingly, this spot should have got the Nobel Prize by Candace Pert. Candace Pert was because she found that this is the spot that has the opiate receptors. And so much of what goes on in modern pain management has to do with this spot even through today. But the periaqueductal gray of the mesencephalon, as a side note, when Candace Pert was robbed of the Nobel Prize in 1973, when she was 26 years old and came up with this stuff working at Johns Hopkins University, she became incredibly vocally pro-chiropractic. If you saw a couple weeks ago, the guy that discovered MRI, Raymond Damandian, he died. He was 86 years of age. He should have got the Nobel Prize for the discovery of MRI. They robbed him of it, and guess what he did? Became incredibly vocally pro-chiropractic for the things that we do that is so interesting. But this is Pain Control Central. And if you take a look at this, that spot, periaqueductal gray, this, if you look at my little graphic, a typical Murphy-Picasso here, nociceptors that initiate the electrical signal that brings pain up into your brain. So the brain is the C, cortical brain, and the electrical signal starts with a receptor, but the receptor, the conduit is interrupted. We call them synapses. And as the conduit goes towards a second order neuron, there is a synapse in the second layer, also known as substantia gelatinosa. And as it synapses there is a movement of neurotransmitters across the synapse. According to the book by Ambron, the primary neurotransmitter is glutamate. And so we can pump the glutamate into an inactive spot with low-level laser therapy. That's one of the great things that we can do. But what I thought was more interesting, if you start looking at the work of Candace Pert, the periaqueductal gray of the mesencephalon drives the raphe magnus nucleus of the pons and the medulla, which then goes into the spinal cord where it drives the descending reticular formation. And then there are pathways that go down and dump inhibitory neurotransmitters pre and post synaptically. So you see my little negative signs pre and post synaptically there. So typically, if you can activate this pathway, they tend to do this with opiate pharmacology because of the opiate receptors. It is really interesting that the raphe magnus nucleus is the primary producer of the neurotransmitter serotonin, which is another whole topic. And he is very clear in his book, Ambron, that the descending reticular formation dumps pre and post synaptically gamma aminobutyric acid. But here's the pitch that I don't know that I knew very well, but I do know it really well now, is that he says the primary driver of the periaqueductal gray of the mesencephalon is the prefrontal cortex, the same spot behind your forehead. So this is one of our favorite spots for pain anywhere in the body to put our laser because it works. It works so well that Erconia Corporation has FDA market clearance exactly for this, which they'll tell you about momentarily, but just showing you this is some of the physiology of it. I wrote a bunch of this up. Periaqueductal gray shows electrical stimulation of the periaqueductal gray could diminish pain without interfering with touch, pressure, temperature. All of this stuff reads excellent, but take a look, and just looking at my clock here, the prefrontal cortex comprises the cortical neurons found in the frontal region of the frontal lobe. Its functions are primarily are probably the most important for what separates us from other primates. An increase in the activity of the circuits of the prefrontal cortex reduce responses to noxious stimuli. Activations of circuits within the prefrontal cortex will have a significant impact on the experience of pain. The modulation of painfulness is associated with an increase in activity in the prefrontal cortex. We know that there are connections between the prefrontal cortex and the periaqueductal gray. The activation of the periaqueductal gray is controlled by circuits in the prefrontal cortex. Inputs in the prefrontal cortex to the periaqueductal gray result in an activation of the opiatergic neurons whose axons descend to the spinal cord, where the release of opioids prevents synaptic transmission at the synapse between the first and the second order neuron of the nociceptive pathway. It inhibits it. Here's the deal. It does it without receptor adaptation. It does it without tolerance. It does it without addiction, that you can get the results with none of the problems that they're having when they chemically try to activate the periaqueductal gray if you do it through the prefrontal cortex. That's the beauty of the whole system. A lot of this is also done quite well in the book, The Angel and the Assassins. If you've ever read this book from 2020, it's a book on the microglial cells. Also in the brain is critically important. What I think is even most important about this, they actually talk about the blinking of the beam. What blinks of the beam will give you the best physiological responses. It's a really nice piece. the potential mechanism of high velocity. It's also interesting that this entire thing that laser is doing is the perfect adjunct for chiropractic. If you'd even just look at this article here by our #1 researcher, Heidi Horvick out of New Zealand, she is adamant what chiropractic adjustments also do is activate the prefrontal cortex. So I just put that reference in there so you can kind of look at it and just kind of being aware of it. One line, my last line before I turn it over. There is evidence supporting that chiropractic high velocity, low amplitude controlled vertebral thrust have significant effect on the prefrontal cortex. The point, we never do monotherapy. Of course, we're adjusting people, but we now can get way better and quicker responses if we can activate the same relays in a different manner. And we're doing that with the applications of low-level laser therapy. With that, I'm going to turn you over to Steve Shanks and Travis Salmons. These guys are pretty much the engineers, brainiacs behind the Erconia Corporation. And I think probably Travis is going to be first. We'll see.
Yeah, thanks, Dan. And thanks
You're welcome.
everyone for joining in here. Are you guys able, or Dan, can you see my screen pulled up here?
I do.
Okay. Awesome. So my name's Travis Salmons. I work with Steve, president of Erconia, as the clinical affairs manager. Steve, you want to introduce yourself?
My name's Steve Shanks. I'm the president of Erconia. Like Travis mentioned, any research that comes through Erconia, our hands are on it. Everything from the FDA to the submissions, and everything else within that process, we're involved in it. We hear a lot of the marketing statements that are out there, and what we really wanted to bring forth to you guys today is how Erconia looks at low-level laser therapy, and we look at more energy than power.
Perfect. So one of the most, I would not even most, really the common misconception out there with laser therapy is power. You go to any trade show, any company's website, power is going to be somewhere on the first page, probably in the biggest and boldest letter. So we want to hit what is power? What does increasing power actually change with laser therapy? With power, you're simply changing the number of photons per second. We'll hit on this on the next slide. It does not change the energy of the photon. And then power does not increase depth of penetration. So here we have a calculator of flux, which is photons per second. If you just plug in the wavelength and then the power output. So this is a 10 milliwatt, 405 violet laser will emit, this is 2 quadrillion photons per second. I had to double and triple check the math, but that is actually what it is. Here to the right is we double the power. So instead of 10 milliwatts, we went 20 milliwatts. It doubles the amount of photons per second. So now you have 4 quadrillion. It does not change the photon energy. So that's one thing that, if there's any take home from this presentation of the 20 minutes here with Steve and I, it's energy, not power. So I'll let you hit that slide there.
So here we're trying to give you how many photons are coming out by wavelength. So like Travis said, if you're using a 405 nanometer, 10 milliwatt laser, you have about 20 quadrillion photons coming out. If you have an 830 nanometer laser, you have 41 quadrillion photons coming out. So basically, to make up for the lack of energy, you're spitting out more photons. So obviously, when you're out in the trade, you're going to hear this: more power gets into better depth of penetration. And we'll kind of go through a lot of those myths and try and dispel those, and kind of you'll understand, hopefully as we get through this, why we do not use a lot of power with low-level laser therapy. So this is something we pulled up off the internet. So the probability of absorption it's pretty small. If you're looking at your eye, if it's exposed to 6,000 photons, it's only going to accept 700 photons for visualization. So think when you shine a laser on your skin, the first law of photochemistry is that has to be absorbed to use in a photochemical process. If what you're seeing is what's being refracted, so you're using an extremely small amount of those photons because the body's just not going to absorb it because it doesn't need it. So what sense if the body can't absorb it all and it doesn't need it? Does it mean to start jacking up the power? You know, we use about, in our handhelds, about 15 milliwatts, or scanners about 25 milliwatts. You have devices out there that are using 25 watts. So, you know, if you've got, 20 to 50 to 10,000 times more power, what good is it? And, you should be able to prove what you're saying back with blinded and controlled research, which is one of the things that Erconia is really good at.
Yeah. So this is a great article that really shows a threshold of power and then potential harm when it comes to laser therapy. So the researchers here made a quote in this study that spreading the 3 milliwatt, which is very minimal power, over a 3.3 centimeter area was less harmful than treating a spot or 1 centimeter per square area. And then kind of put that perspective, as Steve just mentioned with some of our handhelds, one single line or diode on the handheld is 7.5 milliwatts, which typically if you're lasering 3 to 4 inches off the skin, that's going to emit a 6-inch line, which equates to anywhere across the line, each centimeter square is 0.5 milliwatts. If we simply turn the power up to 45 milliwatts, which if you see what's in the field, that's still extremely low. We are right there on that threshold of 3 milliwatts per centimeter square, or DNA damage. And this article here is actually part of the review that Dr. Murphy had there with the biphasic dose response from Harvard. They lasered with the same dose, same joules per centimeter squared, which we'll get into that here in a little bit, with different dose and different time. If you want to focus there on the bottom paragraph is really the take home. The only ineffective dose was 3 joules per centimeter squared delivered with a 50 milliwatt per centimeter squared laser, which took a short amount of time, so 1 minute. All the other doses and power outputs were effective, but they took anywhere from 10 to 100 minutes. So what we're showing here is it's better to spread the energy over a longer treatment time than deliver high power over a shorter treatment time. So more power equals more heat, which is where class 4's lasers come in place. Anything over 500 milliwatts, they're going to be FDA cleared under the ILY category. We'll go through this real quickly. All their intended uses for elevating tissue temperature for muscle relaxation. In order to get a FDA clearance, they have to provide no data, simply performance specs that show that their device can heat up skin temperature anywhere from 40 to 45 degrees Celsius.
And one thing a lot of people don't understand in those class 4 lasers, they didn't come around until 2005. The reason for this is because they didn't have any blinded controlled clinical trials. So if you look at this ILY class, it was grandfathered in 1976 as a heat lamp. So basically a heat lamp topically heated skin. So after that, diathermy wanted to get on the market. Well, they said, well, we can raise the temperature of the skin 40 to 45 degrees Celsius. And as long as they stick to topical heating, they could get a 510K or a marketing statement from the FDA. So 2005 class 4 lasers, which are substantially equivalent to diathermy, which are substantially equivalent to heat lamps. There's no clinical efficacy that they've been proven any better than heat lamps.
So here we have an article, an overview of laser principle, laser tissue interaction, mechanisms, and laser safety precautions for medical laser uses. One take home here was at 42 to 50 degrees Celsius, you have bond destruction and membrane altercations. There in the red mark as a remembrance from the previous slide there, in order for a class 4 laser to receive FDA clearance, they have to heat the skin 40 to 45 degrees Celsius. And article formation of free radicals in human skin during radiation with infrared light, heating to about 45 degrees Celsius, doubles free radical formation and reduces antioxidant power by 50%. Yeah. All right. So kind of put it in a simple diagram I just put offline today. Chemical potential energy. So this is anything coming into the body. Here we're going to say laser therapy. What the body does with it next really shows the effectiveness. So it's either going to produce chemical energy, which is going to be growth, nerve function, ATP synthesis. The other thing it can do is heat exhaust, so thermal energy. So all that heat being lost thermally through hot lasers is nothing but unused or unabsorbed energy.
Can we cover this one?
Yeah, go ahead.
Okay, joules per cubic centimeter squared. This is probably one of the most confusing thing in low-level laser therapy. We've been struggling this with the FDA since we got our first laser cleared in 2002. So normally joules per or cubic centimeter squared is a pretty small area, less than a ½ inch. But because we have a line and we deliver it over areas, moving it back and forth, it's really hard to say joules per cubic centimeter squared. So we usually look at incident dose, and we never have really bought into this joules per cubic centimeter squared. I'll give you a diagram to give you why. And it's so confusing because if you're going to look at an infrared laser to like a visible laser, we have more energy. They have more power. So it should be up to each device to prove to blinded controlled clinical trials how they work and not just a bunch of marketing statements. So this is the Walt recommended doses for low-level laser therapy. Walt came up with this because their research showed that there was so many research projects out there, clinical trials with low-level laser therapy that did not work. Their standard theory to this day is that for deep penetration, you need infrared lasers, and visible light is only good for topical conditions. We believe that this is absolutely because they absolutely do not understand how low-level laser therapy works. And it's why it's so confusing out there because there's so many marketing statements that are proven out to not be true. So we don't really get into this joules per cubic centimeter squared. So this is 3 different books, or 3 different publications that talk about different ranges of joules per cubic centimeter squared. So basically, it depends on who you talk to, which is the most effective dose for joules per cubic centimeter squared. So that book on the far right, phototherapy, couple things that you need to understand is that visible light works through photochemistry. So that'll look laser phototherapy, they're physicists. There is not one article in 1,000 pages in that book that speak to photochemistry. So they don't really understand the basic mechanism is how visible light interacts with tissue.
I can, as Steve alluded to earlier, so why such a large range on the, now it's kind of freaking out here, on the joules per centimeter square? It's because they do not take into account the photon energy. So electron volt energy of a photon is dependent upon its wavelength. Electron volt is measured as EV. Here we have a spectrum of light, wavelength starting from radio all the way down to gamma rays, visible light here in the middle. As you can see, 500 nanometers, which is going to be green, has an EV of 2.4, infrared 1.24. To really dial down to a lot of the wavelengths we see in the field, 405 has the electron volt of 3.06. 830, a common infrared wavelength, has an EV of 1.49. So 70% more energy in 405 over 830. Department of Physics in Georgia State University, a great article, and it really explains the mechanism behind infrared. They quoted that infrared, due to its low EV or energy, is strongly absorbed by water. On the opposite end, visible light spectrum is too energetic for the vibrations of water molecules.
So this is a slide we kind of pulled up to give you a visualization about wavelength and penetration. On the left, what you're going to see is how the sunlight penetrates water. As you'll notice on the right, 800 nanometers, 700 nanometers, highly absorbed by water. This is why you get the heating of the ocean. If you look at some of the shorter wavelengths, the more energetic wavelengths, like Travis just mentioned, it's not absorbed by water and it penetrates right through the water and gets to the bottom of the ocean. Any people that are divers understand when you get that 30 feet of water, all you're seeing is blues and greens. On the right, you're going to see human body is about 99% water. This guy is taking account for all the cells that are in the body. Most people say 60 to 70%. So if all the infrared radiation is being absorbed by water and you're getting topical heating, how does that get into depth of penetration? So we think all the ridiculousness that you need longer wavelengths, more power to penetrate deeper, it's absolutely ridiculous. Anyone knows if you're going to do tissue ablation, you've got we'll call it a 1060 laser that's got 10 watts of power with a focusing lens, and you're going to start ablating tissue. So what the class 4 laser's done is they've taken the focusing lens off, created a beam, taking all of the coherence out of the beam and created a spot. And now somehow that penetrates deeper. It's just absorbed by more water in a larger area.
Yeah, I don't have the slide on here, but at 8 nanometers, if you simply had 2.5 watts of focus energy, you would ablate tissue. As Steve just mentioned, what class 4 lasers will do, take the filtering lens off so it's spread out over a larger area.
Go ahead.
That kind of ties into the paper you found today.
Okay, so this is kind of, this is well published. This is not something we're making up. This is in 3 different publications. You know, visible and infrared lights affect the body in different ways. Visible light creates photochemical effects. Infrared can only produce physical changes, or physical changes are the laser light is absorbed by the water molecules in the upper part of the skin, and they start vibrating. As they start vibrating, you start creating heat. When you're adding more and more power, all you're doing is creating a heating event to eventually you're going to start ablating tissue. So if we could get anything across to you guys, this ridiculousness of infrared wavelengths penetrating deeper is absolutely crazy. We were at, part of our group was at a vet show. This is a multi-radiance, all the class 4 lasers are the same. They use this term photobiomodulation, which we think is ridiculous. But their first page, he says, what is photobiomodulation? Photobiomodulation is a non-thermal process that uses light to stimulate photophysical events within the body. That statement is incorrect. Photophysical events create heating in the body, and they're saying this is a non-thermal process. So they're trying to get around actually what their devices are doing. And when you look at the power of these lasers, they're using a half to 28 watts. So you understand a device that is for photobiomodulation has to be below 500 milliwatts to be considered photobiomodulation, and it does not heat skin. Anything at a half a milliwatt up to 28 watts is going to get absorbed by the water, and it's going to create topical heating, which this device is typically have to get cleared for.
So why is electron volt important? This slide here, again, if you guys want to take it home, ask your sales rep next time, hopefully your sales rep's Arconia, ask anyone at a trade show that's not Arconia how much energy their device has. Probably not going to be able to answer it. If it has less than 1.7 electron volts, which is approximately, or which is 730 nanometers, it is not creating photochemical reactions. As Steve just mentioned, all it's doing is vibrating the molecules and creating a photophysical effect. I didn't know if you were
Yeah.
about to chime
Yeah.
in. So it looks like we're at 20 minutes. I'm gonna skip some of these slides. Kind of hit on a few. So again, this is another more of a diagram if you're a visual person. Infrared, strong absorption, vibrates molecules. Physiological effect is heating, since it is putting molecules into a vibrational motion. This is going to be anything over 1.7, or sorry, under 1.7 electron volts. Visible light, strongly absorbed because it causes electron jumps to higher energy levels, not enough energy to ionize. So in order to ionize, you will have to have at least 10 electron volts, which is in the lower 300 nanometer range. Unfortunately, time won't allow us to hit on this slide. What we're showing with a visible light, having higher EV, you're able to knock these electrons to the highest energy state, or the valence electron orbit, which in turn activates the electron transport chain. The electron transport chain is the main source of ATP production in the body and is vital for life, as Dr. Murphy just went over. There's one big misconception out there: violet or lower wavelengths do not penetrate deeper. We've already proven this, one, through clinical studies. Second, you can prove it through physics. The reason being is when this is a blue wavelength, when it's absorbed, the energy is used and it actually emits a green, and this is called redshifted photon. So this is how you get a systemic effect through violet or blue light.
That was pretty.
Yeah.
So this is a recent study we did at the University of Illinois. We get asked all the time, what wavelength should I use? I will tell you, Erconia, we keep going shorter and shorter, but there's no way I would never not use a red laser. If you want to stimulate mitochondrial activity, you need 635 nanometers. If you want to boost your immune system, interleukin 10, you need a red laser. So again, when we looked at this, we looked at, mitochondrial activity production. We looked at apoptic cells. We looked at reduction of inflammation. We did this with all different wavelengths. So basically, every one of those markers up there was looked at with every different wavelength to compare to control. So each wavelength, as like Travis says, you're affecting the electron transport chain is going to create a different photochemical response. You're not going to get that with an infrared laser because there's not enough energy. So these are some of the things that we proved at the University of Illinois.
A couple more comparative studies. This was looking at the inflammatory effect of low-level laser with our anti-inflammatory effect of low-level laser. 405, violet, green, red wavelength. The level of interleukin 6 was decreased significantly with all wavelengths. However, 405 was the only wavelength to reduce interleukin 6. So that's a neat thing about the more Steve and I do research, depending on the condition, we kind of get the bounce ideas, but it comes down to, okay, what wavelength affects what mechanism in the body. This one here, the effects of light sources on peripheral nervous system, quoted 630 red, 540 green is recommended for nerve regeneration, while infrared light had no difference on the between the control group on action potential of the nerve.
So all that's great and wonderful. Like we said, we have access to it. We do a lot of research. We take the knowledge that we have, that we've done, others done, how it affects different mechanisms, and we incorporate those in clinical trials. Understanding a clinical trial for low-level laser therapy, we were not around before 1976. So all of our research is double-blind, randomized, multi-site, placebo-controlled clinical trials. So I ask everybody, when people are asking some of these class 4 lasers, they'll say they have 40 protocols in them. Okay, what's that based on? Because if you don't have a protocol, you don't run it through a clinical trial, you're treating a condition on something someone's told you, and you get mass confusion like we showed you with all those Walt dose recommendations.
This slide here as well, to clarify, our Coney has 20 different FDA clearances, so 20 different indications for use. Total, we probably have 40, 50.
Yeah.
With FDA, you can file substantial equivalent, so it's a good thing when you're talking to device product manufacturers. Okay, did you submit for a new indication for use? Because if so, it required clinical data, or did you just file for substantial equivalent? Basically saying that your device uses the same specs, wavelength, power output, delivery as a competitor. And then,
So we just real quick,
Yeah,
we'll
go
just
ahead.
kind of go through some of the clinical research. All those theories and mechanisms, they're absolutely great. It allows us to apply different wavelengths as we're doing clinical research. So this is research that we've done. We've combined them all together. As most of you know, we have indications for overall chronic pain. We have overall post-surgical pain. But Travis, you could just kind of walk them through this. These are some of our pain compared to placebos. And again, we've been using LEDs as placebo device since 1999.
yeah, so this is actually published recently in the Orthopedics and Rheumatology Journal. It's all, like Steve mentioned, all of our pain articles combined. We did a full statistical analysis on it. It's 5 double-blind studies, 419 total subjects. The VAS is visual analog scale. That's how you measure pain on a scale from 0 to 100. The reduction in pain for the laser group, and this is immediately following treatment, was 45%. For LED, 15%. Neat thing here, if you follow these same subjects out 2 to 4 months, you see the initial placebo effect diminish. So laser group actually increased, because you are increasing ATP and the growth factors, from 45% reduction in pain to 62% reduction in pain. LED group went from 15 to 14%.
So we kind of documented the same thing on fat reduction. We won't get into this right now, but you can see that from where we see it, LEDs, they make for great placebo devices.
Yep. And I think that we'll leave the remaining 15 minutes here for questions. Dan, I'm not sure if I need to buzz you back in or if you're able to do that on your side.
I am buzzed back in. So, but before I ask you guys questions, is that okay if I ask you guys some questions about what you just did?
Sure, absolutely.
Okay, well, first thing is I just want to make sure for the audience that's listening, Steve Shanks, smart guy, he says IL-10, he even said the word interleukin 10. Just so you know, interleukins are cytokines. And we're all familiar with cytokines now because of COVID-19 and the cytokine storm. As a consequence of that, Michelle is doing my video. Thank you, Michelle.
You're welcome.
Just remember, cytokines are proteins that are made by immune system cells. Some cytokines are inflammatory, some are anti-inflammatory. The leader of the anti-inflammatory cytokines is called interleukin 10. If you've ever read that book, Younger Next Year by Chris Crawley and Henry Lodge, great book for anyone that wants to live to be 100, which is all of us. They actually say interleukin 10 is the magic that you want. It is anti-inflammatory, it is regenerative, it is restorative. Consequently, one of the things that separates the low-level laser, red laser therapy, is significant elevation of the magic you want, interleukin 10. So that was really nice that Steve Shanks sort of mentioned that. I just want to make sure I cleared it up a little bit. Steve also said Walt, and he didn't actually explain what is Walt. He just blew out this word, and he says, Walt says, like, who's Walt? Is he like a buddy of yours, Steve? Who's Walt?
The World Association of Laser Therapy, which is now
the big dog in laser therapy, right?
Yeah, now they changed their name to the World Association of Photobiomodulation.
Okay, so that's pretty cool. I had a little bit of trouble with your presentation, and Travis, I've done this one of yours, because you showed the calculator, which I love, but the numbers, you get into the quadrillions, you don't have any commas on those numbers. It's very difficult for the eye to kind of pick up on that. I mean,
Yeah.
it's hard to, when you do a comparison, because when you compare a quadrillion to a trillion, just at a glance, you can't actually perceive the difference without some commas in there or something like that. So I just want to make sure I kind of mentioned it up for you. I'd also tell you that, believe it or not, Travis, you did the best thing. I'm hoping the audience picked up on it. I don't know if they did, but my undergraduate degree is in chemistry. So I know chemistry. And yet, even though I know chemistry, I still forget it and I want to know it. And you realize that all physiology, you can never say all, but I'm saying it, all physiology occurs as a consequence of the electrons in the outer shells of atoms, everything. And what the laser does, it elevates electrons from a lower shell to a higher shell. And all of a sudden it changes every facet of physiology. And then as Travis showed, it can fall back down to a lower level, and in falling back down, it can release another source of energy. So you just get a double bonus on that. It is a fabulous topic. That lasers can do this is unprecedented. And he said, though, if you get too much energy, which would be undesirable, you can actually elevate the electrons so much that you elevate them right the heck out of there. You eject them, and that's called ionization. That's what X-rays do. So we don't want that sort of energy. We want energy that raises it without ejecting it. And then that's what the electron volts do, the violet versus the green versus the red, etc. If anyone's into this, if anybody wants to understand it to a greater degree, read the book Chemistry for Dummies. I've read that book. It actually has pictures quite similar to the one that Travis showed, how the laser elevates the electrons to a higher shell, changing all the physiology with a double bonus. When the electron falls back down, you get another spark of energy that is measurable in yet a different wavelength. So that's some of the really awesome things that can be done out there. And so, Steve, if it's okay with you, I'm the whiplash guy. I lost a whiplash case by using a laser that was not FDA market cleared. So I'm just curious. I mean, you just showed us the thing that you have 20 FDA market cleared lasers for based upon your own work without, filing for similar, same and similar, whatever your language was that most companies do. You actually did your own work for 20 of them. You got the FDA market clearance. I'm most proud of using the first one, 2602, because that's for chronic neck and shoulder pain, which is what I do as a clinician. And a lot of you chiropractors, particularly doing whiplash, are actually doing that. Can you just give me kind of a very brief Reader's Digest? What does it take to get, and first off, what does 510K FDA market clearance, what does that mean? And how difficult is it to get one without making an application for same and similar? What does it take to be the originator of an FDA, a 510K FDA market clearance? Can you just tell me in a Reader's Digest, what does that mean? Or Travis, or one of you two guys?
Yeah, so a 510K marketing statement is what we're allowed to legally market. It's basically a license from the FDA saying that we can legally market for chronic neck and shoulder pain. For us to legally market for chronic neck and shoulder pain, we submit protocols to the FDA, we get them back, we go to IRB, we run a clinical trial. That process is anywhere from 2 to 5 years. In the case of chronic neck and shoulder pain in 2002 and low back pain, which I think was 2016 and 2017, the FDA didn't accept our first clinical trial. So we had to go back and redo the clinical trial again, although both those clinical trials were mimic the first clinical trial. That's what it takes sometimes to get a market clearance from the FDA. So
in other words, very expensive, very time consuming, very, labor intense in order to do it. And you guys are doing it. And that's, you're funding all of that research, which I know can't come cheap. I know you just blow off the words, because you do. IRB, Institutional Review Board. These are things that are required for the FDA even to give your work a look at all. So you have to do all of these specific protocols. I know because I just noticed when you went through the thing, you have FDA market clearance for acne, but you also have FDA market clearance for chronic low back pain. Now, your chronic low back pain FDA market clearance, is that what wavelength? Is that just the violet, or is it just the red, or is it a combination, or what do you got?
We did our first clinical trial on chronic back pain with red. The reason why we did it then, because that's the predominant wavelength that we were using. We've since, gotten it for red and violet, which you're seeing us switch over to a lot of the red and violet. by combining those wavelengths. We're getting better results. We can go back on our original clinical trial on neck and shoulder. And then we go back to our clinical trial on neck and shoulder with red violet, which was a lot more efficacious on pain and also range of motion.
You mentioned that you have FDA market clearance for pain anywhere in the body. Which one of your lasers achieved that?
Well, that was about a 20-year process. So as we got neck and shoulder and plantar fasciitis and low back pain, those are all blinded controlled clinical trials. We approached the FDA and said, look, we've already done foot, back, neck, shoulder. We would like an indication for overall chronic neuromuscular pain because it doesn't make sense for us to keep going back and doing the same clinical trials over. And the FDA agreed. So based on, those 4 different areas of the body, the FDA gave us an indication for overall chronic neuromuscular pain.
I know you spent a little bit of your time bad mouthing some of the other products out there, but just, is there any other company that has FDA market clearance for, like, let's say low back pain? Because remember, 63%, if you look at the Adams study from Spine coming out in December 2017, the number one reason that people initially go to chiropractors is for chronic low back pain, 63% of the people. Does anyone other than Erconia have FDA market clearance for chronic low back pain?
They do not. And as far as I know, I don't know of any device that the FDA has cleared besides our FX laser for chronic low back pain.
Yeah, and we got one. I mean, so we use it, we love it. I mean, we do low back pain. And then of course, 30% of the people that go to chiropractors do so for neck pain, which is my thing. And so, and that was your first FDA market clearance all the way back in 2002. So that's pretty good. Can you just talk to me a little bit? I know you did a pretty good job. Travis did a good job. Hey, what about putting a violet laser on the brain? I mean, what about that? I mean, I just, it is kind of something new. Who's going to take it?
Well, I'll take it. So you're talking about lasering on the brain. Part of our protocols for whether it's a red laser or a violet and red laser is we treated the same side cerebellum and the top of the head. So we've been treating the brain with the laser since 1999. It's been through all of our clinical trials. The Institutional Review Board, the IRB, approved all that. So, when you look at joules per cubic centimeter squared, like my forehead, we measured it, it's 100 cubic centimeters squared. So if you're going to say that 10 joules per cubic centimeter squared is the maximum that you should treat that area, it would take my forehead, I'd have to treat my forehead for like 11 hours, over 11 hours to get 10 joules per cubic centimeter squared. So that's another reason why we don't buy into this joules per cubic centimeter squared. We think by treating a larger area where that area of the body is going to absorb more energy and moving the device back and forth is a lot more efficacious than just say putting on a skin with a dot laser.
Okay, great. Now I was to make sure I got that. So you're putting the laser on the vertex of the skull and on the cerebellum bilaterally.
Correct.
And what's your indication? And you're getting for what reason? This is for chronic pain?
Yes, for chronic neck and shoulder pain. So our thought process at that time was same side cerebellum controls same side body function. We use the governing vessel 21, which is an acupuncture point. When you're in a clinical trial to get an FDA clearance, it's blind. Everybody gets the exact same protocol.
Okay.
So that we treated those areas along with the spinous process in the area of pain.
Okay, so you're not putting it on the neck or the shoulder. How are your outcomes?
Our outcomes, like Travis showed, it's about 63% pain reduction after one treatment, along with increased range of motion.
And then after the end of the clinical trial, the benefits continue to be shown even after the stopping of the intervention while the placebo group started to regress. Is that my understanding of that graph, Travis?
Yes, and it's actually interesting if you compare neck and shoulder pain between the red only and the red violet study. Both worked great, diminished pain right away. Interesting enough, the EVRO, which was the 4.0 violet and red combo, had greater results at 24 and 48 hours compared to red alone. There is an article that I pulled up earlier. Didn't have time to really dig into it too much, but it showed that the 405 or violet seemed to reduce interleukin 6 at 24 and 48 hours, while red did it immediately. So I mean, it may be an explanation of what some of the results we're seeing there.
Yeah, Dan, you talk about long-term effects, which obviously we're looking more and more into. In our low back study that was FDA cleared, we followed those patients out 1 year. So those patients continue to get better 6 months to 1 year out than after we stop treatment.
Okay, and so just bear with me here for a second. And I just want to try to make sure that I'm catching up.
I'm going to interrupt everybody because I've got questions for both of you that I'm going to read to you, and then you guys can decide who answers it.
Well, can I finish my
Yeah.
stuff first, or do you want to
Just
do it
let you
first?
know.
Okay.
No, just keep
Okay,
going.
so when Steve Shanks, for the audience, when Steve Shanks says interleukin-6, that's the bad guy. That's the pro-inflammatory guy. If you read again Crawley and Lodge's book, Younger Next Year, they say there are 100 bad cytokines. The general in charge is interleukin-6. The fact that you can drop it with low-level laser therapy in a quick and meaningful way is it's just unprecedentedly great information, which is undoubtedly why you got the FDA market clearance, because your outcomes are so good. That's part of the reason your outcomes are so good. I'd also I'm just kind of shooting the breeze with you a little bit. I know that you guys have gotten so much research going on. Is there any projects that you have coming up that you think are exceptionally exciting for this audience, just to hear about some of the stuff that we can see in the future?
Probably the up and coming one, Steve and I actually just did a midpoint audit, is diabetic peripheral neuropathy.
Awesome.
That study where we're using red and violet combination. I know you did a pilot study with Dr. Carrie Zhang, podiatrist in Arizona, where they did nerve punch biopsies. And
Yeah, we were looking at small nerve fibers in the bottom of the feet. So in these diabetic patients, we noticed that we could regenerate small nerve fibers. We actually did publish that study.
So when you say punch, you mean you are histologically checking out the tissues pre and post intervention.
Yes, looking at under a microscope.
Yeah, and I'm really excited about doing a peripheral neuropathy, a diabetic peripheral neuropathy. That's good. And is it possible, Travis? Can you share how are the outcomes? You said you did a mid-study audit. How's it looking?
it's looking good.
Okay, cool.
Yeah,
Yeah.
And I've known you guys since I had to switch to you guys before my med legal work. 20 years ago this year is when I switched over to using uriconias. We have, I think, like maybe 8 of them in the office now. It's a big part of our clinical practice. Everyone gets laser. And I've noticed that you've moved from Arizona to Dallas to Florida, et cetera. I'm just wondering, it just seems to me like you keep kind of growing and getting bigger. Well, I mean, is your business expanding? I mean, what's going on with you guys?
Yes, we have we have about 4 employees in London. That covers most of our European assets. We're getting more publications out of Europe. You could talk about the clinical trial we ran in Europe that we ran, so.
Yeah, so for the treatment of toenail fungus is the current.
Yeah.
Vascular edema.
Yeah, we had one of our Polish clinics ran vascular edema, blinded controlled clinical trial. That data looked amazing. That should publish soon. Just today, one of the obesity clinics published another study on our Emerald product. What other clinical trials we have? Stanford, if you're going to be at our partners meeting this year, Leon Morales, who's a neurologist, he's doing some research on strokes, and he's also doing on complete severed spinal cords. He's going to present some of that research. These are pilot studies. One day they may turn into clinical trials.
We have
Well,
another
just-
speaking doctor there from VCU, Virginia Commonwealth. He's doing a study on erectile dysfunction.
Okay, and the nitric oxide connection and all that, I think that's exemplary. Steve, where is the partners meeting? I mean, partners, I mean, I'm not a partner, neither is anyone on this audience. Can anyone go to this? What's up with that?
We call it a partners meeting because we bring in a lot of our international distributors. It's actually a golf tournament along with the seminar, along with our international distributors.
And this is open to clinicians so they just contact so where is it? Where is the physical location this year then?
It's in Orlando, Florida.
Okay.
The Hyatt is where they play a lot of the really nice golf.
And when is it?
It's November.
November 3rd or November the 5th.
Okay,
Yes.
that sounds very awesome. I mean, I like that. When I do my last word with you, I know exactly what it'll be, but my Michelle says there's a few questions from the floor that we should probably entertain, if that's okay.
Yeah,
One more thing about our partners meeting, we do have Danica Patrick, will be there kind of talking about. her,
Really?
Yeah, she's been a big advocate of ours.
Yeah, that's awesome. I want to lap around the track or something like that. I mean, that'd be fun. What's your questions, Michelle? What do you have?
okay. One of them is compare and contrast the Accelerate and the EVRL as an introductory laser for a chiropractic clinic. Who wants to take that?
The Accelerate is probably the first laser that we started out with, which is the Accelerate's, it's 2 red laser beams. We decided to add the violet laser, which is the EVRL laser. Later on, probably 6 to 7 years later, if you're going to start out, the Accelerate's less expensive. It's those same red wavelengths. We used in chronic low back pain. We used in peripheral neuropathy, chronic neck and shoulder pain. As we've gotten older, as we've been around more, think we can make the technology better. We started adding the violet laser, which is a lot of the research we're doing now. So going forward, you can see us combining more wavelengths.
I would just add in that I travel nonstop with Michelle. We travel with the Accelerate. And it's just, because we do a certain protocol on ourselves every day, mostly for our brain. Steve, you're traveling nonstop as well. Are you traveling with a handheld?
I do. Wherever
Which one?
I will usually use the EVRL
Okay.
just because I know it's a little bit better than the red for, chronic pain issues and stuff like that. And like you were talking about, knocking out some of the inflammatory stuff when you're traveling, everything that you're supposed to. The red's going to boost the immune system. The violet's going to help knock down some of the inflammation.
Okay, that's good information. The red alone is a little bit less expensive. So for people want a true introductory one, that's the one. But the violet is just, the outcomes on the violet are just changing things so rapidly that I think that it's probably in all of our futures sooner or later. So if people want to get on the front of it, I go EVRL. Does that sound fair?
Yeah, that
Yeah.
sounds fair.
Okay, Michelle's.
Okay. Has the EVRL been upgraded? I last purchased mine 5 years ago.
Yes, we upgraded it 3 months ago,
Yeah,
maybe 6 months ago. We made it lighter. We added, that laser has the ability, because a lot of the stuff that you'll see that we do is pulse frequency. So you could do a linear and non-linear in that laser where you can adjust, say you're treating the brain. We know the frequencies of the brain are constantly moving from about 1 to 60 hertz. You can either run it linear or you can just have it just throwing frequencies at the body all the time. We didn't touch much on frequencies, but we definitely believe in pulse laser therapy.
That's one of the next question is where does frequencies come into play, like plugging in different protocols in the FX405?
Well, give me a second on that before you guys do that, just for the audience, because some of you are more green than others. EVRL is Erconia red violet laser. It is a handheld device that is just slightly larger than your cell phone. And Steve travels with it. I travel with a similar device, but mine is red. The EVRL is red and violet. So just we're clear on the terminology. And then that question was about the pulse frequency.
Yes. Where does frequencies come into play?
Frequencies for us started probably back in 1999. Up to that point, we were using constant wave. As soon as we pulsed the laser, everything for us seemed to change. I had to prove to myself that the pulsing actually worked. At one point, we hired the #1 low-level laser researcher in the world on wounds. He did a series of rats compared to placebo and did different pulsations. They all healed at a different rate. So like I was mentioning with your brain, your alpha, delta, theta, beta waves, they're constantly changing and they're all over the place. So if you want to hit one frequency from each area of the brain, you can plug those into the laser. If you want to hit with some of our newer technology, a range, you can plug that into the laser. We know your nerves fire. My opinion is that the brain knows a frequency of firing. sitting here, you can hear my voice, I can hear the air conditioning, I can hear Travis tapping his foot. Your body can handle all this stimulus. So we feel by adding more pulsations we can add to the laser, the greater effect we can have in the nervous system and the efficacy of the laser, which is really what we prove in our clinical trials.
Okay, this one is, I have not been able to understand the differences of various PBM devices that have various power levels and the differences of joules produced in treating various health conditions.
Yeah, I
Help
hope,
me understand.
I thought they did that in this
Yeah.
presentation.
Yeah, I
I
thought
thought
they
that that's
did
what you
too.
did.
Yeah,
so for simplicity's sake, a 1 watt laser will put out 1 joule in 1 second. A 10 milliwatt laser will put out 1 joule in 100 seconds. That paper that Travis showed, delivering that energy over time is more efficacious than treating it in 1 second. So like Dan, you brought up that article 2, biphasic dose response. It gets into this treating over time is much better than 1 big incident dose. But this joules per cubic centimeter squared is why we really don't buy into it. Because if you have a red laser, a violet laser, a green laser, and an infrared laser, and you're all going to treat them with 1 joule, you're going to have a whole lot more electron volts in that violet laser than you're going to have in that infrared laser. And if that infrared laser is not creating photochemistry, all it's doing is vibrating the water molecules. It's up to the manufacturer or the person selling you that laser. Why did you use this amount of energy or this amount of power? And that's the confusing part about low-level laser therapy, because 99% of it is marketing. With Erconia, we're 100% science, which we back up with marketing. And interesting, I had a meeting with the FDA. Virtually 90% of all research that is done at the FDA is substantial equivalence. It's not blinded and controlled. So there's a lot of substantial equivalence going on and a lot of marketing and not a lot of science.
Okay, so I think we're pretty much there with from the floor questions. I'm done with my questions. Other than that, I have an ending comment, unless you guys want to go first, or if you want to go last.
No, well, you can end. You're much better at this than we are.
Okay, so a lot of you are trying to get your head around this, as I have been for 20 years, and where my head is at the moment is that what we desire is photochemistry. That's keyword, chemistry, photochemistry. Photochemistry uses photons in the visible spectrum. This is things like violet, blue, yellow, green, red. All of these are things that we can see. That's photochemistry. Each of those have different abilities to do different chemical entities, but it's photochemistry. In contrast, there is another whole category of lasers, and that's photophysical. Photophysical is because the photons cause vibration. Vibration causes heat. Photophysical uses infrared lasers, longer lasers. So you sacrifice the photochemistry, the healing photochemistry, you sacrifice it for heat generation. And that's not what we do when we do our cases. We want to accelerate healing, which requires photochemistry and not photophysical things. Did I say that okay, you guys?
I thought you said it perfect. Yeah.
Okay. So that's all I have. I know we went a little over, but that's all I have. But anything that you guys want to use in your final moment, go for it.
No, I think you wrapped it up perfectly.
Okay. Well, I want to thank everyone for listening to us. That was kind of fun. Hey, Steve and Travis, you guys have any more of these coming up?
I don't know. We have to talk to our
That's a good
sales
question.
department. If people want to, I mean, we could talk about this again, but right now I don't think we have anything planned, maybe till sometime next year.
If people want to know some more information, what do they do? I mean, do you have any other podcasts? Do you have any other seminars? I mean, what's anything that this audience should know should they want to take it to the next level? Anything?
Yeah, absolutely. So Erconia.com, you can visit the website, full list of seminars. I believe we still host 2 to 3 on-site seminars per weekend. From a podcast standpoint, I think, Dan, you were just in one a couple of weeks ago. We now have 20 podcasts, the Laser Light Show complete. We're scheduled to actually record 100 podcasts. They're great. They're short. I believe they're 10, 15 minutes. So enough, during lunch, you can sit down and watch them. To access those, you can go to arconia.com. And you can actually preview them on, I believe it's Apple or Spotify.
And then, of course, you guys sponsor full 12-hour hands-on workshops by a variety of top-tier instructors. Like you have Trevor Barry, the neurology diplomat from down in Arizona. You have Kurt Gare. I mean, you guys have great speakers. I listen to them as often as I can. So that if anybody is so inclined, those are also, I'm sure, listed on your Arconia webpage, that they can find the hands-on workshops that are, you got to go to location. It's not like the podcast. You go there and you can really fine-tune your skills. Am I right?
Yeah,
Yeah.
absolutely.
Yep.
Yep.
Okay. Well, then I'm saying goodbye to you guys.
Bye, Dan. Good talking
All right.
again.
Same here. And goodbye to the audience. I'll talk to you. I'm sure I'll see you on the road sometime.